Assalamu alaikum, my dear students. I hope to be fine. Today we will talk about present value of annuity. Present value, recall from chapters simple interest and compound interest, the concept of present value or discounting. If we expect to receive or pay specific amount of money after a specific number of periods, and we want a specific rate of interest on money today, we can find how much this future value worth today by finding the present value. So a present value is a process by which we can discount future value expected to be received after a number of years using interest rate as a required rate of return or discount rate by applying the simple equations by putting in numerator the future value expected to be paid or received divided by 1 plus interest rate we are required to get or we will pay as a cost of money power in periods of time. The second component of our title today, we talk about present value of annuity. Last lecture we discussed the concept of or the definition of annuity. When we talk about equal and periodical cash flow to be paid or received over a specific period of time, we talk about annuity, not single amount. If this equal and periodical cash flow are expected to be paid or received at the end of each period, we talk about the first type of annuity, which is ordinary annuity. But if these equal periodical cash flows are expected to be paid or received at the beginning of each period, we talk about the second type of annuity, which is annuity due. Our objective today is to find present value of annuity. Let me show a simple exercise about Ahmed, who borrowed loan from CIB Bank by which he pays $700 annually. But Mr. Ahmed opened another account at EG Bank and asked the EG Bank to buy his debt from CIB Bank. Ahmed pays $700 at the end of each year. So we talk about ordinary annuity over 5 years, over the next 5 years, which means he will pay $700 per year over the next 5 years. If each bank requires minimum rate of return of 8%, how much should each bank pay to CIB Bank to purchase Ahmed's debt? In short, each bank wants to find the present value of expected cash flow received from Mr. Ahmed, received by each bank from Mr. Ahmed at the end of each period over the next 5 years. If each bank requires interest rate 8% on the amount each bank will pay today, so they are required to find present value of ordinary annuity. By the definition of ordinary annuity, the amount will be paid by Mr. Ahmed at the end of each period. All of you know any timeline depicts periods at the end of each period. So at the end of the first period, which is year 1, each bank expects to receive the first $700 from Mr. Ahmed, and the last amount expected to be received from Mr. Ahmed at the end of year 5. Each bank wants to identify how much each amount expected to be received from Mr. Ahmed worth today. So each bank will apply the simple equations of present value, which is S divided by 1 plus I power n. The first amount, the first 700 to be received from Mr. Ahmed will be discounted by dividing 700 by 1 plus 0.08 power 1 will be 648. Second amount received by each bank from Mr. Ahmed will be worth today 600. We can apply using this the calculator by dividing 700 by 1 plus 0.08 power 2, because it will be received after 2 years, equals 600. What does it mean? The 700 received after 2 years, it worth today 600. And the third amount received by the each bank after 4 years, it worth today 514. The last amount expected to be received from Mr. Ahmed, it worth today 476. So each bank will pay how much to buy this portfolio of financial obligations of Mr. Ahmed from CIB Bank. Each bank will pay $2,794 to CIB Bank, by which each bank can receive the expected payments will be done by Mr. Ahmed over the next 5 years. How we get 2,794? We simply add up all the present values calculated using the expected cash flow over the next 5 years. But as you see, this method takes several steps, so it is called long method. And we talk about annuity, so we can use shortcut equation. Shortcut equation by which we can find the present value each bank will pay today by multiply cash flow 1 equal periodical cash flow, which is 700 times factor called present value interest factor for annuity. Actually, this factor can be got by two methods. The first one, the present value interest factor for annuity table. This table is called the present value interest factors for $1 annuity discounted at interest rate, specific interest rate for specific number of periods. So the first column show number of periods, and the first row show the interest rate applied. The second method is to calculate this factor mathematically by applying these equations, which is 1 minus 1 divided by 1 plus I power n divided by I, which is the discount rate. In our exercise, we have cash flow of 700 expected to be paid annually over the next 5 years, and we will discount 700 at 8%. So we can go to the table to find the present value interest factor for annuity discounted at 8% over 5 years. So we go down in the first column to year 5 and to go to the interest rate row under 8%, we find 3.9927. This factor is a present factor present value interest factor for $1 annuity discounted at 8% for 5 years. The second method is to calculate the present value interest factor for annuity mathematically. By applying these equations, we can show this by using calculator. 1 minus bracket 1 divided 1 over 0. Over 1 plus 0.08 power 5, close your bracket, enter, divided by 0.08, I will get 3.99. So we can use this factor by we can multiply this factor by the one equal periodical cash flow, which is 700. So that we can apply the standard equations, multiply the one equal periodical cash flow, which is 700, will be paid by Mr. Ahmed annually, by the present value interest factor for annuity, which is a 3.9927, we will get $2,794. What if Ahmed pays the $700 at the beginning of each year? This is the second type of annuity, which is annuity due. And each bank requires 8%. So each bank needs to find the present value of the expected 700 to be received at the beginning of each year. So the given 700 at the beginning of each year over the next 5 years, and each bank requires 8% as a rate of return. Each bank wants to find how much this expected cash flow worth today in case of annuity due. By the definition of annuity due, the amount expected to be received at the beginning of each year. So because the timeline depicts periodical at the end of each period, so at the beginning of year 1 is the same to say at the end of year 0. If we want to depict any amount at the beginning of year 1, we can put it at the end of year 0. And the amount which is due at the beginning of year 2 can be put at the end of year 1. So any amount here is due on the beginning of the next year. So the first amount expected to be paid by Mr. Ahmed will be due at the beginning of year 1. So we will put it at the end of year 0. So the first 700 is paid at the end of current year. The second 700 will be paid at the end of year 1, which is due at the beginning of year 2. The third amount, 700, is expected to be received at the end of year 2, which is due at the beginning of year 3. So the last amount will be expected to be received at the end of year 4, which is due at the beginning of year 5. The task of each bank now is to find how much all expected cash flow over the next 5 years worth today by applying these equations. The first amount each bank expect to receive from Mr. Ahmed is 700, but the first 700 will be received at the end of current year. So once each bank buys the portfolio of debt from CIB Bank, the first installment of debt will be received from Mr. Ahmed. So there is no time spent from the first amount received from Mr. Ahmed. So there is no opportunity for increase in the price level, which is inflation, and there is no risk of losing this amount. So the present value of any amount will be received or paid today is the same amount. So the present value of the first 700, which is expected to be received at the end of current year is the same value. So present value of 700 is 700. But the second amount will be received at the end of year 1. So we will discount this amount by dividing 700 by 1 plus 0.08 power 1 equals 648. So the second amount expected to be received from Mr. Ahmed at the end of year 1, which is due at the beginning of year 2, it worth 648, and so on to reach the present value of the last amount, which is due at the beginning of year 5, which is received at the end of year 4, which is 700. It worth today 514. So we can add up all the present values to find total present value which is paid by each bank to CIB bank, which equals $3,018. This method is a long method, and because it takes several steps, we can use shortcut equation by multiplying the cash flow times present value interest factor for annuity. The first method to get this factor is from the table. The second method is to calculate it mathematically. We observe extra term multiplied by present value interest factor for ordinary annuity. Our exercise each amount received from Mr. Ahmed equals 700 over the next 5 years, and each bank requires 8%. So find the present value. To find the present value, we have to calculate the present value interest factor. From the table, we can get this amount, which is 4.3121 from the table. If you go to the table from present value and interest factor for annuity due over 5 years and at 8%, we will get this factor, which equals 4.3121. We can use this. We can get this value by applying these equations mathematically. 1 minus 1 divided by 1 plus 0.08 power 5 divided by 0.08 times 1 plus 0.08. Let me show using calculator. 1 minus open bracket 1 divided by 1 plus 0.08 power 5 close brackets, enter, and divide this amount by 0.08, enter, 3.99, which is present value interest factor for annuity, times 1 plus 0.08, we will get 4.3121. We will multiply this amount by 700 to get to $3,018 in one step. So we can compare between annuity due and ordinary annuity. If we expected to receive each 700 over the next 5 years at the end of each year, this is a case of ordinary annuity, by which each bank expects to receive 700 at the end of each year over the next 5 years. So if each bank wants to find the present value of the next 700 expected to be received 5 times at the end of each year, he can use these equations by multiplying the one amount, which is 700, times the present value interest factor for annuity to get or to pay 2,794. But if each bank expects to receive 700 at the beginning of each year over the next 5 years, and each bank wants to find the present value of all expected cash flow, can apply the equations implies multiplying 700 times present value interest factor for any ordinary annuity times 1 plus the interest rate, which equals $3,018. Sure, you observe there is difference between ordinary annuity and annuity due. Even we have the same amount, which is 700, and will be discounted as the same interest rate over the same number of periods. But because of the timing of cash flow, here in ordinary annuity, it will be received at the end of each period, but in annuity due, it will be received at the beginning of each period. So time spent to receive each amount of annuity due is shorter than the same amount in the ordinary annuity. The first amount of 700 in annuity due will be received sooner than the first amount received by each bank in case of ordinary annuity. In annuity due, the first 700 received at the end of current year, but the first 700 in case of ordinary annuity will be received after 1 year. So in annuity due, the present value of 700 will be 700, but the present value of the first 700 will be 648 because there is time spent in case of ordinary annuity. So time spent to receive each amount in annuity due is shorter than the same amount in ordinary annuity. The second amount received by each bank in case of annuity due, it will be received after 1 year and it worth 648, but the second amount received in case of ordinary annuity will be received after 2 years, so it worth 600, and so on. So the present value of annuity due is always greater than the present value of ordinary annuity. Note that if you have a table of present value of annuity, if you have table of present value interest factor for ordinary annuity in your exam, and you want to get present value interest factor for annuity due, the difference between annuity due and ordinary annuity is the term of 1 plus I. So we can use this factor, which is of ordinary annuity, and multiply it by 1 plus I to get present value interest factor for annuity due. So present value interest factor annuity present value interest factor for annuity due equals present value interest factor for ordinary annuity times 1 plus I. In our example, present value interest factor for annuity due equals 4.3121. If I don't have this table, which is in 5 and 8 equal 4.3121 directly, but we have the value of present value interest factor for ordinary annuity, we can take this factor and multiply 1 plus I will get the present value interest factor for annuity due. The last topic today, we will introduce if you have annuity equal amount of cash flow but for not a specific period of time, but for infinity life. Continual annual cash flow. If you expect to receive, for example, $500 at the end of each year forever. This is not ordinary annuity, but it is called perpetuity. Perpetuity. So if a perpetuity pays an annual cash flow starting 1 year from now, we can find the present value of the cash flow stream by simply dividing the annual cash flow by the interest rate required. Let me give you a simple exercise. If Ahmed wishes to into a bed in 357 hospital, which means Ahmed wants to finance one bed in this hospital. One bed in 357 hospital needs 240,000 Egyptian pounds per year. The hospital can invest the endowment paid by Mr. Ahmed today at 8% annually. How much Mr. Ahmed has to pay today to finance the 240,000 annually? So Mr. Ahmed wants to calculate the present value of 240,000 needed to finance one bed annually forever. So the required, we must determine the present value of 240,000 Egyptian pounds, perpetuity discounted at 8%. Simply, we can divide 240,000 by 0.08, which is a discount rate. So we will get 3 million Egyptian pounds. What does it mean? Mr. Ahmed, to generate 240,000 Egyptian pounds every year for an indefinite period, requires paying 3 million Egyptian pounds today. If the hospital can earn 8% on its investment. In other words, if the hospital can get 8% as the rate of return annually on 3 million Egyptian pounds, it can withdraw 240,000 per year indefinitely. In short, Mr. Ahmed wants to finance one bed in hospital 357. One bed in this hospital needs 240,000 Egyptian pounds per year. The problem is that Mr. Ahmed wants to calculate how much he should pay today to finance 240,000 per year. If the hospital can use the amount paid by Mr. Ahmed today at rate of return equals 8%. Say the hospital can deposit the amount paid by Mr. Ahmed at the bank at 8% to get 240,000 per year as an interest. So how much should Ahmed pay today and invested by the hospital at 8% to get interest, annual interest of 240,000 per year? So this is a case of perpetuity. We can find the present value of perpetuity by dividing the amount, which is equal amount, which is 240,000 in our case, by the interest rate we will get the present value, which is 3 million Egyptian pounds. Thank you. Next video, we will discuss future value and present value of mixed stream of cash flow. Assalamu alaikum.